All right, good morning, everybody. So sorry for the delay. YouTube was giving us a lot of difficulties. So me and the other teachers that are teaching this way, we're having difficulty starting a Hangout and broadcasting. So it was basically kicking us out every time we tried to do something. So I'm very, very sorry for the delay. I'm glad you're all here and joining us. So we lost some time, but that's okay. We can make it up. So I hope that you guys all had a great weekend, that you weren't too stressed for the last 20 minutes that we weren't going to have a class, but we are here, we are ready to go. So the plan for today is just while we're getting started, I just want to talk again about the SIPROB, and then we'll get into any questions you had from the material from Friday, and then we'll continue on with the new material. So first of all, for the situational problem on Wednesday, it starts at 8:30 sharp. You have exactly 2 hours, no more time than that, because then some people have to go to science and it gets a little confusing. So make sure you're here on time. If you're late, you will not be given any extra time. So make sure you are here on time. You can have your memory aid. I posted a big list on Friday. I'm going to cut that down just to make it a little bit easier for you. So I'll be giving you a shortened list this afternoon, probably around 1:30, and that will give you a bit of a better idea what to expect for the SIPROB really. So it just gives you a little bit more to focus on rather than such a broad idea. Remember, you should be building your memory aid really for this and for the final, thinking about just having one memory aid and just progressing and building onto one document. So that's the situational problem. The chat's on the side. If there are any questions about the situational problem that could maybe benefit the class, now would be a good time to ask. So everyone's clear about the situational problem. You have to be here for 8:30. Memory aid, pencil, calculator. There won't be many of those hanging around extra if you forget them, so make sure to have them. Be here 8:30 sharp, and I'll be posting another list, a shortened, more precise list for the situational problem this afternoon. Okay, so the plan for the week is today we're going to be doing new material. Tomorrow we're going to be doing new material. Wednesday's your situational problem. Thursday we'll be doing new material, and if all goes as planned, part of Thursday and all of Friday will be for practice final exam questions and assignment questions to go over, because like I explained to you, those assignment questions are final exam level, so we need to be able to handle those type of problems. So on Thursday, probably the last 20 minutes, half an hour, we'll start the review, and Friday we'll start the review, and that'll be that. Over the weekend in the notes folder, I uploaded 2 practice finals. So they're just practice finals. So so you can take a look at those, and we can go over a lot of those questions on Thursday and Friday. And then be prepared for your exam on Tuesday. So the list that I will be posting this afternoon is the stuff that will be on the SIPROB. That is fair game for the SIPROB. If it's not on the list, it's not on the SIPROB. You do not have class on Monday. Friday is our last class together. I will be reachable by email well, I'm always reachable by email and up to like 8 o'clock the night before, 9 o'clock the night before. Won't be answering emails much past that, but no, you don't have class on Monday, but you can always reach me by email. Tomorrow, can we have like 10-15 minutes just to review? I can do my best to leave about 10-15 minutes at the end for you to just ask me questions. I won't be reviewing in a formal sense, but I could leave 10-15 minutes at the end to just go over any questions that you have. But if you don't have any questions, we will keep on going. You can find the final exam schedule on that here. I'll show you. So I'll just screen share here. So if you go here on the Leicester the Pearson School Board website. Where it says Summer School 2017. And then you have the July 2017 supplemental exam schedule. So you go here, Tuesday, July 25th. You have the Sec 4 Math C2 Reasoning, your Sec 4 TS. So it's Tuesday, July 25th from 9 to 12. Do not miss it. Any other questions about the final or SIP prob? We can't have a formal class on Monday, no, but you can, Friday's class will be a tutorial where we will be going over problems and you can ask me questions. And after that, I'll be reachable by email. Anything else? What's left to learn? It's a good question. So today we started probability a bit on Friday. Today we have some probability stuff to do, and tomorrow we have some probability stuff to do. And then on Thursday, we have a bit of statistics. So we'll just do a very quick review of the stuff that you learned in CST. And then we have two other little things to cover for statistics, and that's it. So two main probability things. We have a lot of little things just to look at today to build up for what we're actually doing today and what we're doing tomorrow. So there's two main like big topics. And one of those questions often comes up as a part A-B. So the stuff we're doing today often comes up as a part A-B question. And the stuff that we're doing tomorrow almost always comes up as a part C question. So we're going to be covering that. And then on Thursday, we'll cover the statistics and just be done with it. So it's actually very, very similar to mean deviation, just different. So yes, now would be time to ask me some questions. We don't have a lot of time to do some review today. We do have to move along because we do have to cover everything. But if you have any questions on the assignments or anything, we'll take 10-15 minutes to go over that now. But after that, we really have to move on. Okay. So we have two questions so far, so I can go over both of those two. Anything else? So far I have assignment 10, number 2, and just a quick review of distance point to line. Yeah, we can do 2 and 3. Okay, so we'll get started then on assignment 10, number 2 and 3. So number 2 looks like this. So this is a more complicated exponential equation that we're supposed to be solving. So in this case, what we are doing is, remember, we want to isolate this term so that way we can use our log relationship. So the first thing I'll do is divide by 4. So 324 divided by 4 gives me 81. From there, I can use the log relationship. So this goes down on its own. And then we get log of this divided by log of 3. So if you type that into your calculator, you get 4. And then if I bring this over, x is 6 plus 4, which is 10. Is that clear? Okay. Number 3. On the same day in January 2010, Daniel bought a truck and Jack bought a car. So this is number 3. Since then, the value of each vehicle has decreased annually with respect to its previous year's value. The following function describes how the value of Daniel's truck has decreased.
It's working now?
Yeah.
You know that for your SIP prob day, you're going to class 3 through 4, right?
Yes.
Okay.
Thank you. Okay. So here I have this rule, 31,000. So this is for Daniel. So Jack paid $25,000 for his car in January 2010, and since, oh, this is in assignment 10. You're right. Sorry, this is assignment 9. Okay, we can do number 2, but not number 3 because we actually haven't learned the material for number 3 yet. The -6 was a part of the problem. This was part of the rule. So this just drops together, okay? So my apologies, we'll move to assignment 10, number 2. So assignment 10, number 2, we have 2 bacterial cultures are studied in a laboratory. The number of bacteria in culture A doubles every 30 minutes. So we'll say culture A. Okay, so what do we know about culture A? Well, first we know we're going to have y equals AC to the x over d. We need to figure out what our parameters are. So it says doubles, so this means C is 2. And if I define x to be doesn't really matter. Hours. So that means D will be 0.5. And I have the same thing for culture B, y equals AC to the x over D, where C is 2, but in this case, D is 1 over 3 because it's every 20 minutes, which is every third of an hour. So here we know that we have A 2 to the x divided by 0.5. And here we have y 2 to the x divided by 1/3. This, if I have x divided by 1/3, that's the same as x times 3, okay? Remember, we flip fractions when we multiply. So I'm just going to write this as 3x, okay? Now, it tells us that 1 hour after the start, so when x is 1, we have that y for the first one is 384. And when x is 1 for this one, we have y is 24. So here what we want to do is we need to solve for our a values. So I know that 384 is going to be my a to 1 divided by 0.5. So here I can solve. 1 divided by 0.5 gives me 2. 2 to the 2 gives me 4. And if I divide by 4, I get 96. So this rule can now be completed. I'm going to do the same thing here. 24 equals a 2 to the 3 times 1. So that just gives me 2 to the 3. 2 to the 3 is 8. and I get 3 as my A. So we have y equals 3, 2 to the 3x. Now we want to know when they're going to have the same amount of bacteria. Same amount of bacteria means the same y. So we know when we're solving for the same y that we take each of the equations and we set them equal to one another. So here I'm just going to write this a little differently. X divided by 0.5 is the same thing as 2x. Okay, so I'm just going to write it that way. Now I want to manipulate this so that I have one exponential equation and one number. So here I'm going to divide by 2 to the 2x on both sides. So that gives me 96 equals 3, 2 to the 3x divided by 2 to the 2x. And I'll divide both sides by 3. Okay. So 96 divided by 3 gives me 32. Now, remember that when we divide something that has an exponent, this is going to give me 2 to the 3x subtract 2x. So that just gives me 2 to the x. When I'm at this point, I can change using my log relationship. So x is log 32 over log 2. So x is 5. So 5 hours after the start, they're going to have the same amount of bacteria. Okay, we'll do a quick distance point to line question and then we'll move on. Assignment 10, number 3, we're about to cover, so we can go back to those type of questions. Distance point to line we did on Monday. Okay. So we'll do on this handout, we'll do number 4. So we are calculating the distance between A, -5, and 2. So we have -5 and 2, and the rule of the line that we have is x plus 2y minus 4 equals 0. So here what you want to do, you have this formula. So what you want to do really is just identify the parameters. So we know that this rule looks like this. So that means that my A is 1 because it's the number attached here. The B is 2 and the C is -4. The X we're given is -5 and the Y we're given is 2 because the X and the Y come from the point we're working with. So then here I just plug everything in. So this gives me A is 1 and we have -5. B is 2 and the Y is 2 and C is -4. Now we are careful here that the A and the B are the A and the B. So I have 1 squared and 2 squared. It has to be in general form. Otherwise you don't have the A, B, and the C. So then I start to manipulate this. So here I get -5 plus 4 minus 4. On the bottom, this gives me the square root of 5. So this just gives me -5 over the square root of 5. But remember, the distance can't be negative. So once we get to this point, I just drop all of this, which gives me 5 over the root of 5. And if I type that into my calculator, 5 divided by root of 5, that gives me 2.24 units, whatever the units were. So here, really what you are doing is you are identifying the A, B, and the C, and the X and the Y. And once you have those 5 different numbers, you just plug them into your formula. Okay, if there are no more questions, we'll move on. We do have a lot of stuff to cover today. So we're in probability. So we're going to do a couple of probability things quickly. You do cover probability in Sec 1, 2, and 3. All right, so let's take a look. So we started talking about probability and random experiments. We did a quick review of geometric probability and arrangements and combinations. So we've gotten to here. So we talked about a combination when you have different things that you're doing, different steps with different values. So we're looking for different combinations in that point. So just a refresh, we are in notes number 10. We'll be finishing off notes number 10 today, and then we will be taking a look at notes 11 after. So a permutation is an ordered sequence of objects. So the important part of this is that order matters. So something like ABC is not the same as ACB. Even though it's the same combo, it's not the same order. So it's not the same thing. So what ends up happening is if we're taking these things and we're ordering them, it's the same idea here where we take the first step times the second step times the third step times the fourth step. But what ends up happening is if we have n things, we have n things the first time. But once we've put something in the first position, then we've taken one away from the group as a whole. So then we have n minus 1 things to choose for from step 2. And then we remove something else for step 2. So in step 3, we have another one that's less. And this continues until we run out of numbers. We represent this as what we call a factorial. So if you see the number with an exclamation point, this means factorial, and it only works for permutations, which means that you have a group of things where the order matters. So what is a permutation? So when you have the exclamation point on a number, you're taking that number and you're multiplying it by every number that's less than that until you get to 1. So n factorial is 4 times 3 times 2 times 1. That gives me 24. What this represents is if I have 4 things to put in order, there would be 24 different ways I could put them in order. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. And that gives me 720. So if I'm ordering 6 different things, there are 720 different ways I could order them. You won't get something like 1,000 factorial because your calculator cannot handle that big of a number. Even 12 factorial might be big. But there is a button on most calculators, most of the scientific ones, not all of them, but some, where you actually have the factorial button. So on mine, for those of you who have the Sharp calculator, it's Shift 4. You see there's an N and an exclamation mark. So if you just type in 12 and that button, it'll give you the answer. 479001600. Or you can do it by hand, which is fine too. You really won't have to do many of these. We just have to look at them. So how many different ways are there to place 4 books on a shelf? Whoa, I meant to make that bigger, not smaller. How many different ways are there to place 4 books on a shelf? Well, if we think about it, we have the first book. How many different possibilities do we have for the first position? Well, we have 4 different possibilities. After that, we have the second position, but we've taken a book out of the mix. So we only have 3 books left to work with. And then for the third position, we only have 2 books left because we've put the other 2 in there. So we have 2 books left to choose from. And then the fourth, we have 1. So this is just 4 factorial. And that gives us, like we just calculated, 24. You could also see this as this type of problem where 4 people are applying for 4 positions. So you have, again, first position. You have second, third, and fourth. And it's the same idea. Third is not a TH, third is an RD. Jeez. 4 people are applying for 4 positions. So I have 4 people to choose from for the first position. But then someone's in their position. That only leaves me 3 left to choose from here. Leaves me 2 left to choose from here. And 1 left to choose from here. So that's the same thing, 4 factorial, that gives me 24. So the difference between permutations and combinations is that in a permutation, the order matters, right? Like if I have somebody, I'm going to have these 4 people no matter what. They're just going to be in different positions. So the positioning of those people matters versus a combination where if I have a bag of marbles containing 7 blue, 5 green, and 8 red, find the different combinations of marbles if we pull out 3 marbles from that bag. Well, it's asking me for the combination. So if I pull out 2 blue and 1 green, it doesn't matter if I pull out the green first or the blue first. I'm still going to end up with 2 blue, 1 green. So this, you could actually, the only way to calculate this one would be for us to, like, you can write it out and find all the different combinations. We're not going to do this because it's not a good use of our time, but the idea of combinations and permutations, the thing you have to understand is a combination means that combination, that grouping is the same no matter what order they happen in, versus a permutation where the most important thing about a permutation is the order that it happens in. So we're just going to do 1 or 2 quick examples here for probability. A coin is tossed 3 times. Provide the possible outcome for getting a total of 1 tails. So if we're talking about A is our event, remember, so a total of 1 tails could happen in 3 different ways. So you could get heads, heads, tails. You could get heads, tails, heads, or you could get tails, heads, heads, right? So that is the outcomes. Those are the possible outcomes for getting a total of 1 tails. Getting tails on each toss just gives us 1 outcome in our event. So that should be a B, obviously. 1 outcome for our event, and it's getting tails on each toss, which means it's tails, tails, tails. Vanessa shoots a basketball 3 times, and S is a success and F is a fail. Give this set of all possible outcomes. You can do this for a practice. Like I said, this isn't really a good use of our time, but For example, you would start off with 3 successes, and then you could change the last success to a fail, success, fail, success, success, fail, fail, and keep going on from there. But we are not going to do this all. And then remembering just quickly that a certain event is guaranteed to happen. So you could say getting a success or a fail. Well, obviously that's going to happen because one of the two things has to happen. And an impossible event would be getting 4 successes because she only shot the basketball 3 times. So that's impossible. So just remember those 2 terminologies. So this brings us just to finish up this part of it. You had problems like this in assignment 10 and in handout 10. So this will allow us to finish those up. So odds and probability. Okay, you do this in secondary too, but we do need to refresh our memory a little bit because sometimes you get questions like this in a part A or part B. So odds and probability, this is something that you see a lot when it comes to sports and sporting events. So what are the odds of this happening, or what is the probability of this happening? So basically what this is you're given information about a probability, but if it's in odds, it's presented differently than if it just said, well, the probability of this happening is 1/2. If they say the odds of that are 2 to 3, that's a little bit different, but there's a relationship between them. So there's a relationship between the odds of something happening and the probability of something happening. So odds are always written for chances for ... chances against. So if I say the odds of a team winning are 2 to 3, that means the chances for is 2 and the chances against are 3. Unless they say the odds against. If I say the odds against them losing are 10 to 2, that means the chances against are 10 and the chances for are 2. So we'll just take a quick look at creating the odds. The odds of rolling a 3. So we want, remember, chances for to chances against. So if we're rolling a die, we have 6 possibilities, right? So we want rolling a 3. That's what we want. So we want 3. How many are there? Just 1. How many are not 3? 5. So the odds of rolling a 3 are 1 to 5. This is not the probability, those are the odds. The odds of rolling an even. So again, we want how many evens? So we have 2, 4, and 6. So we have 3 evens. How many odds do we have? 3. So evens, non-evens. For and against. The odds against rolling a number less than 5 means that I want the number. So if it's against, these things flip around. So if we're doing the odds of rolling a number less than 5, we have 4 numbers less than 5 and 2 not less than 5. But we want the odds against. So we flip them around. So probability, there's a relationship between these and the probability of something. So to get the probability of A, some event, we have the number of outcomes that are favorable to A divided by the total number of outcomes. which is actually the odds for divided by odds for plus odds against, because the total number of outcomes is odds for plus odds against. So just remember here, just quickly, remembering we've seen probability before, we kind of understand this. Probability is a number between 0 and 1. So remember that if you get the probability of something is 2, then you've done something wrong. So what are the odds for, odds against, and probability of rolling a prime number on a die? Odds for. Now, I don't know how you were taught, but some of you have seen 1 as a prime number, and some of you have been told that 1 is not a prime number. How many takers on each? Just give me a little show of hands in the chat here. 1 prime or not prime? Most votes I get, that's what we're gonna go with. Fabulous, we've already got 5. 5 for prime. Ooh, 1 against. So for just the purposes of this, okay, we're gonna consider we'll consider 1 to be prime just for the purposes of this question, okay? We're not gonna get into the philosophical, is it or is it not? We're just gonna do the probability question, so that's okay. So in this case, odds for would be how many prime numbers are there? So there would be 1, 2, 3, and 5. So there would be 4 versus 2 non-prime numbers. Odds against, we just flip these 2 numbers to give me the odds against, which means 2 dot dot 4. The probability of odd is chances for divided by the total. So how many primes are there? There are 4. Out of how many possible? Well, there's 4 prime and 2 not prime. So that gives me 4 over a total of 6. And this can reduce to 2 over 3. When we remember, we always want to reduce probabilities as much as possible. Okay, let's do number 3. A card is drawn from a deck. What are the odds and probability for the following? Odds for drawing a queen. So how many queens are there? 4, remembering that there are 52 cards in a deck. How many non-queens are there? 48. That makes the probability of a queen to be 4 divided by, we add these 2 numbers to give me the total. So that's 4 divided by 52, and that's going to reduce to 1 over 13. Remembering that you can use your fraction button to do the reducing for you. The odds for drawing a heart, how many hearts do we have? We have 13. How many non-hearts do we have? 39. So the probability of the heart would be the 13. So we take this number and it just goes on the top. And then divided by, we add these 2 numbers to give us the total. Because it's either a heart or a non-heart, that gives us everything. So that gives us 13 over 52, which is 1 over 4. Odds against drawing an even. What this means is we want the even on this side and the non-even, or odd, my gosh, just said non-even. odd on this side. So in this case, we have 4 2s, we have 4 4s, we have 4 6s, we have 4 8s, we have 4 10s. And you consider a queen an odd. So I have an even, sorry. I have 24 even cards, and that gives me 28 odd cards. The probability of not even in that case, oh, I just did it again. So silly, eh? Would give me 28 over 28 plus 24, which gives me 28 over 52. And you can reduce that to 7 over 13. Is this clear for everybody? So let's just do these 2 examples very quickly just to make sure everything's clear. Determine the probability of the following based on flipping a coin 3 times. So when we're finding the probability of heads, 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 each of these has a different probability. So what we're actually going to be doing is taking the probability of one heads times the probability of the other times the probability of the third. So what is the probability of us getting heads the first time? Is 1 over 2. Probability of flipping a head on the second is 1 over 2, and same for the third. So that gives me 1 over 8. Probability of getting tails on the first toss. So that could happen with tails, heads, heads. That could happen with tails, heads, tails. That could happen with tails, tails, heads. Or that could happen with tails, tails, tails. So what happens here is we're going to look at a simpler way to calculate these probabilities tomorrow, but for just today's purposes, each of these has its own probability. So tails, heads, heads, we know we just did this. It's going to be 1/2, 1/2, 1/2. Gives me 1 over 8. Same thing with tails, heads, tails. Tails, tails, heads. And then finally we get tails, 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 which is the same thing. Now the total probability of tails on first toss, we're going to add these up. So we get 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8. That gives me 4 over 8 or 1/2. Good? Okay. This one's a little bit more complicated. So the reason I wanted to do this question is this question will help you with number 3 on the assignment 10, number 3. So once we do this problem, you should be able to do that one. Sure, I can. We good? So I have a bag of purple, green, and orange marbles. I know that there are 300 marbles in the bag. The odds of getting an orange are 1 to 4. The odds against getting a green are 10 to 3. How many of each colored marble is there? So here's what I'm going to do. I need probabilities. So probability of orange. We have the odds. So we have 1 over 1 plus 4. So the probability of orange is 1 over 5. The odds against green are 10 to 3. So the odds for green, we just switch them. So the probability of green is going to be 3 over 3 plus 10, which gives me 3 over 13. Actually, can you just do me a favor and in the problem, can you change this to a 2? So 2, 2, 2, 2, 2, 12. If the probability of getting an orange is 1 over 5, and I have 300, if I just take 300 and multiply it by 1 over 5, that's going to give me the number of orange marbles. So the number of orange marbles is 60. I'm going to do the same thing with the green. If I have 2 to 12 or 2 over 12 of green, if I multiply that by 300, I'm going to know how many green there are. So 300 times 2 divided by 12, that gives me 50 green and 60 orange. So if the total is 300, how many purple do I have? So purple is going to be total minus the orange and minus the green. So that gives me 300 minus 60 minus 50. And that actually gives me 190 purple. So doing this question, if you go to assignment 10, number 3, just quickly to explain it. Oh, actually, this will help you with assignment, the quiz 10, the forms. Number 3. So question 3 on the forms is exactly like this one. You have a certain number of marbles and you have odds. And you have to figure out how many of each color marble there are. So you could do that one now. Number 3 on the docs is when you have 4 different games and you have either the probability or the odds. So what you have to do for each of these games is figure out the probability of winning. Because when you're comparing them to see which one has the higher probability, you need the probability. So for each of those 4, figure out the probability of winning. And then you can compare them and say, okay, which one has the greatest probability of winning? So is that a little bit more clear for assignment 10, number 3? Two or 3 people asked me that this morning, so is that a bit more clear for those 2? For that problem, I guess. Okay, cool. Try it out, and if you're still having difficulty, we can go over it tomorrow. No problem whatsoever. Okay, cool. So So that brings us to today's notes. Scrolling down. All right. So what we are going to be doing today is we're going to be using, we're going to be talking a lot about Venn diagrams. So if any of you, I know this isn't the case for most of you, but if some of you have already done grade 11 CST, if you're graduated and you're doing this for the credits, this probability stuff will be review. If not, then that'll be new. Pretty much everything, if you've done the grade 11 CST, will be review for probability. Okay, so we're going to talk about Venn diagrams, and then we're going to talk about what we can do with them. So you've seen a Venn diagram before, probably in your other classes. So we are visually representing situations when we're looking at Venn diagrams. So what this is this box that we have represents everything. So that's what our universal set is. So if we remember what our universal set is, it's all the different outcomes. So everything in our situation will have its own place in the box. Each circle represents a different situation, a different event. So one circle would be event A and one circle would be event B. Oftentimes you have them, oh no, this isn't gonna save nice. Just let me reopen this because if I don't, already it's not going so well, no. Make sure here. You know when you're having technical difficulties, or you know you're having difficulties and really none of it is something you can control, like the YouTube thing this morning was not pleasant. And now Smart Notebook has decided to be a big pain. So we're gonna try this for a third time. No, I don't. Fine. There we go. Okay. Oh my gosh. Here we go. Okay. We are good to go. So. Maybe the universe is telling me that you shouldn't learn probability. Unfortunately, then you won't be very happy if you get a part A question, a probability, and a part C question, and that's 14% of your exam, which is completely possible and highly likely. So we have our two different events that are represented by our circle. And normally what we end up having here is we have the circles intersect. So we have this intersection point, or like intersection region. And what that is it's where it's the different outcomes that A has and that B has. And we represent this by A intersection. Or we even just say A and B, because it's something that's in A and in B. So that's the little intersection point of our loops. So if we do an example of just representing this, something here, by a Venn diagram. So rolling a prime, again, for our purposes, because we voted that one is prime, we're going to have this. And rolling an even, 2, 4, and 6. So here we have our A. And here we have our B. So what we do is anything that's in A just gets put in A. 1, 2, 3, 5. But then we notice the 2 is also going to be there, so we put it in the middle. And then the 4 and 6 aren't that, so we just keep it on the other side. And all of the numbers happen to fit in A or B, but we could have had them in the universal. So if they don't fit in A or B, they would go on the outside. In the exam, if you get that on the exam, I'll come around and answer that question, okay? They almost, when they do probability questions, it's usually not with prime numbers specifically for that reason, because they know that some people teach it with prime being one being prime, and some don't. So they don't try to, they're not trying to see what your teacher taught you, which case scenarios. But I'll answer that if that comes up. Okay, so an incompatible or a mutually exclusive event is when there's nothing in this intersection. For instance, we have rolling a number less than 3. So if we call this A, rolling a number less than 3 is 1 and 2. If we call this B, rolling a number greater than 4 would be 5 and 6. On the outside, we would have 3 and 4. And notice we have nothing in here. So rolling a number less than 3 and rolling a number greater than 4, we call this incompatible, meaning there's nothing that goes in both cases. When we put the union of two events, so union is represented here by this symbol. We read this as A or B, meaning our solution set is anything that's in A or in B. When we say and, it has to be in both. When we say or, it's the two of the groups together. So it's their sum. So if we represent this again, rolling it an even number, so we call this A. So an even number would be 2, 4, and 6. But rolling a number greater than 3, so 4 and 6 is going to go here. And a number greater than 3 being B. And we have 5. And then we would end up with 1 and 3 on the outside, because in our box, we have to have all the different possibilities. So in this case, A or B would be everything that is in this circle. So A or B would end up being 2, 4, 5, 6. So anything that's in the Venn diagram, we just leave out what's on the outside. What we call complementary or contrary events are two events that have nothing that's the same, but when we put them together, we get everything, the whole universal set. It is not possible that it doesn't fit in A, B, or U, because anything that doesn't specifically fit in A or B just it's in U. So contrary events are two things with no overlap, and that when we add them together gives us the whole universal set. So the two ways of representing this are the A bar, so that means A and A contrary of A, or A and A prime. We're going to use this one more so than the other, but just be prepared if they throw this at you that that's what they mean. For instance, rolling an odd number, if this is our A, we would have 1, 3, and 5. Rolling an even could be our B, 2, 4, and 6. So essentially, when we put these two together, we get 1, 2, 3, 4, 5, 6. which is everything. So notice how there's nothing in the U that's not in the A or the B, and this is empty. So what this means is instead of calling this B, we could call this A prime, because it is what completes A to make the whole set. Does that make sense? So when we're solving for, like, you're going to just get a situation. It may not even tell you to make a Venn diagram. So you just have to know that you have this as a tool. So we're going to make a Venn diagram and find A prime for the following situation. So we're rolling a 6-sided die. Event A is rolling a number greater than 2. So we're going to write out the universal set. We know that the universal set, since we are rolling a die, is 1, 2, 3, 4, 5, and 6. And we have event A is rolling a number greater than 2. So here we have 3, 4, 5, 6. So event A prime would be anything that's missing. So we could say 1 and 2. And if we wanted to write this out in words, just figure out a relationship that would give you these two. Not you. A prime, if you wanted to write this out in words, could be rolling a number less than 3. So that would mean A and A prime are contrary. All right, let's do another one. You roll a 6-sided die. Event A is rolling an odd number. So A would be 1, 3, 5. B is going to be a number greater than 3, so 4, 5, 6. So this is my B. So I have 4 and 6. In my A, I have 1, 3, and the 5 goes in the middle, and the 2 goes on the outside. What we are looking for is this. So this is actually a little bit weird terminology. So first we're going to find A intersection B. Now A intersection B, if we remember, is this. So A intersection B is 5. Now if we're taking this part of it, not, so we read that as not, like N-O-T. So even here we would write A, and A prime means not A. Whatever's not in A. So if we have this, we have A intersection B, so we have A and B. And then we have this, which is not A intersection B. So essentially, what is not in here? So what is not in here? Well, 1's not in there, 2's not in there, 3's not in there, 4's not in there, 6 is not in there. That makes sense? So if they just ask you for A not B, A intersection B prime, it's a little bit harder to just try to figure out, but when it's visually represented in a Venn diagram, it makes it a lot easier to fish out the information that you're looking for. So then what happens? Are there any questions? Two, So remember, event A is rolling an odd number. So the odd numbers are 1, 3, and 5. So 2 doesn't go in there. B is rolling a number greater than 3. 2 is not in there, so it doesn't fit in either of the bubbles. So it goes on the outside. 5 is in the middle, but what you have to understand is that we have this bubble. This bubble. So if you look, 5 is actually within the blue bubble, right? And then here, five is still within the red bubble. Okay, so it's just within both. All right. So now we have these laws. So these laws are on your mock memory aid, and you can put them on yourself as well. So if you look at the mock memory aid, I didn't click that at all. Good grief. Sure, just open whatever you want. Okay, forget it. If you go on the mock memory aid, you will see that you have these different probability laws. So you can just put them on, but make sure you understand what they mean. So this is kind of like when you have a binomial squared, how you don't just put the square. We remember, if I have this is not the same thing as saying x squared plus 9. So you don't just distribute the squared term, or 3 squared, just to visually see it, to both of the terms here. So this is the same when we are doing this, okay? So just so we know, the lines here are the same as the primes. So if you have A or B prime, what this means is not A intersection not B. And same thing here, we'll do it with the lines as well. If you have A intersection B, so A and B, but the not of that, that's the same thing as saying not A or not B. Those are what we call De Morgan's laws. And it's just a way of us seeing this a bit easier. Okay, so let's take a look at what this looks like in a Venn diagram. So we're just going to fill out the Venn diagram first. So event A is rolling an odd number. So we have 1, 3, and 5. Event B is rolling a number greater than 3. So this 5, we have the same Venn diagram as before. This 5 pops in the middle. B, we have the 4 and the 6, and we have our 2 on the outside. So here we have this. So what this turns into is A prime, and we flip the U, and B prime. A prime is anything that is not in A. 4, 6, and 2. B prime is anything that's not in B. So 1, 2, 3. I want this means and, so it's something that's in both. It's only 2. So that's what we get. Okay. A 6-sided die is rolled. Event A is rolling a number less than 4. So we can fill out event A. So we have 1, 2, and 3. Event B is rolling an odd number. So actually we're going to have 1, 3 in here. And just 5 in here, which means that 4 and 6 are on my outside. What about the 5? The 5 doesn't matter. The 5 is both in A and B, so it's not, so remember this is not A. So since the 5 is in A, it can't be here. The 5 is in B, so it can't be here because remember this is not B. And then what we're looking for is the intersection. Okay. So remember here, if we have A intersection A and B prime, this means A prime or B prime. So what we are going to do is A prime is anything that is not in A. So that gives me 4, 5, and 6. So these are the things that are outside of the A bubble. What is outside of the B bubble? 2, 4, and 6. When I put this symbol there, what this means is I'm just putting all of these together. So I have a 2, I have the 4, I have the 5, and I have the 6. I don't need to put the 6 twice. There's only one 6. It just so happens that it's in both, but I don't really care. So that is what we get, not A or not B. So far, so good? Okay. Okay, we have to get through those at least. Okay, difference event. When you see this, A minus B, what this means is A occurs, but B does not. So what we are doing is we are taking away anything that's in the intersection of them. Leaving what's in A, but taking away anything that's in B. Same thing here. If we do B without A, what this means is B minus A. So it's everything that's in B, but that's not in A. Example. We're going to use a die a lot, but this obviously extends to anything. So event A is rolling an odd number. Rolling a number greater than 3. So we set up our Venn diagram. A without B, what this means is we are taking A, but only what's in A, we're cutting out what's not in B, what is in B. So A minus B ends up being just the 1 and the 3. Does that make sense? So when we're subtracting what can be found in B. Let's look at this. A student is chosen at random from grade 10. The students have just completed 2 exams, history and mathematics. Event A is that the students pass math. And event B is that the student pass history. So A would be pass math. B would be pass history. What would be the intersection? Would be if they passed both. So AUB would be the kids that, so that would be this part here. It would just be the kids that passed both. So A and B would be just the kids that passed both. Here we have the same representation. So here we would have A without B, means this region here, but you don't include this little section because we want to take away the thing that's in B. And same thing here. So in this case, we want B without A, which means we want everything in B that's not in A. So we want this whole section here. So far, so good. We're pretty comfortable with Venn diagrams because we're going to be using them. Okay. Laws for probability. So we have different, like we talked about Venn diagrams, but Venn diagrams is more just for the representation of something. It doesn't actually give us the probability. So here are different relationships for probability. So these are things that should just plop right into your memory aid, and we'll do some problems with them just to get your mindset going. But for the most part, these are just laws and you just apply them. So we know, first and foremost, that probability is a number between 0 and 1. So you can't get a negative and you can't get a number bigger than 1. If you have an event that has different outcomes, the probability of that big event, you just add the probability of each individual outcome. For example, event rolling an even number. So the probability of rolling an even number, which would be a 2, 4, or a 6, we would add each individual probability. So the probability of rolling a 2 is 1 over 6. The probability of rolling a 4 would be 1 over 6. And the probability of rolling a 6 would be the same. So I add them up, and that gives me the probability of rolling an even. Probability, I guess I should have reversed these two things, but the idea is the probability of something is whatever the outcomes are in A divided by the total number of outcomes. So the probability of a 2, there's 1, 2, there are 6 outcomes. That's how we get the 1 over 6. The other way to look at this is we could have done this one that way. So probability of A is we have a 2, 4, or a 6. That's 3 out of the total of 6 outcomes. And that gives us the same thing. The probability, just again, as a definition, the probability of the universal set is 1 because it has all the outcomes. The probability of the empty set is 0 because it has no outcomes, so it can't happen. These are important. So the probability of A or B is going to be the probability of A plus the probability of B, but minus their intersection. Because what ends up happening is, if we go back to this example, let's say. So if we just take a look at this one here, for instance. So it's on the previous page, 2 pages behind, number 2. We set up this Venn diagram. I'm going to use this Venn diagram just to illustrate my point, okay? So you have A and you have B. So we're saying that the probability of A would be I have 3 in there out of a total of 6. And the probability of B is 3, again, because I have 3 in B, over 6. So if we want the probability of A or B, you would think that we just add them up, right? In theory, but that gives me 6 over 6, which gives me 1. But there are 2 possibilities out here that aren't accounted for. And what happens is if I just add these 2 up, this portion here ends up getting counted twice. So we have to take it away. So the probability of A intersection B is the probability of A plus the probability of B minus their intersection. So I just messed up 2 things here. Obviously, that's not a double A. And this turns around. So we don't want to count the intersection twice, so we minus it. So here, if we do the probability of the intersection, we have 2 out of the 6. So then here we get 3 over 6 plus 3 over 6 minus 2 over 6. So that gives me 4 over 6. And now that makes sense because A and B would be the circle here. And we have 1, 2, 3, 4 things in it. So we have 4 out of 6. Does that make sense? So we have similar things down here. If A and B are mutually exclusive, if they have no overlap, that means they have no overlap. So this would be 0. So you would just say it's the probability of A plus the probability of B. The other ones here is the probability of A minus B. So remember when we took out the B part, the overlapping part would be the probability of A minus the overlapping part, because that's what we did to represent this in a Venn diagram. We took A and then we took out the B. So the probability is the same. It would be the probability of A minus the probability of the intersection. And the probability of B minus A is the same thing. We take the probability of B and we minus the intersection. The last little law for probability is that when we have 2 things that are complementary to each other, meaning they add up to give me the whole universal set, then the probability, in theory, what this can be written as, is the probability of A plus the probability of A prime. Because when I add these 2 events together, I get the whole universal set. And we know that the universal set has a probability of 1. When I add up their probabilities, I'm going to get 1 as well. So that's just another way of representing this. So what we are going to be doing tomorrow, this just gave us some Venn diagram practice. So some of the assignment today and the handout today is Venn diagram practice, but most of it is the stuff we didn't get to because of the little internet lovely YouTube issue. So you can save that for another time. Oh, did it go down? It was like a central thing for a lot of users. That's what we figured because we tried it on different computers and different browsers and different internet. It was everybody. So we apologize for that issue, but definitely out of our control. So you can save most of this handout and this assignment for tomorrow. Remembering that even though you have your sit prob, don't fall behind. If you have any questions, feel free to email me. Check out the post this afternoon with the more precise list of topics, and then we'll take about 15 minutes tomorrow just to review those topics and make sure you're ready for your sit prob. But like I said, if there's any questions between now and then, send me an email. This afternoon, I'm going to be giving you feedback on assignment number 9. And so you should check out for that. And if there are no other questions, have a great afternoon. Sorry again for the mishap this morning. And we will see each other tomorrow.
Thank you.
Thank you. Thank you.
You're welcome.
Thank you.